In this section, we want to talk about power and polynomial functions, some of their properties and how we solve problems with those types of functions. First, we want to talk about how we recognize these different types of functions. So a polynomial function is a function that consists of one or more terms, each with a variable raised to a power and a coefficient. For instance, we could consider a function g of x is equal to 6x squared plus x plus 1. This is a polynomial because it has one or more terms, each with a variable, though if we look at that last term, it's just plus 1. The reason we say this has a variable is because we could include here x to the 0 power. We don't because anything raised to the 0 power is just 1, but that concept is still there. Raised to a power, our second term, x isn't being raised to a power, but that's just because we don't write to the first power, since that doesn't change the value of a number. And a coefficient. Our second term is also missing a coefficient, but similar to how we don't write that exponent, we don't include 1 times a variable. So something can meet those characteristics even if it doesn't necessarily look that way, the way we write out functions. Power functions are polynomials with just a single term. So for instance, just 6x squared. Now what you might notice is that the function g of x that I provided here is actually a quadratic function. And I just said that a power function is a polynomial function, just a polynomial with one term. So what we have here are some overlapping definitions and expressions. And what I would suggest, if that kind of feels confusing, is to think of the idea of a shirt. So shirts cover the upper half of your body, but depending on whether you were maybe going to a baseball game in the summer or a football game in the late fall, it might impact the kind of shirt you want to wear. So in the summer, a t-shirt or even a tank top that doesn't have the word shirt in it versus a sweatshirt or something long sleeve in the late fall. Tank tops, t-shirts, sweatshirts all fall into the general category of shirt, but adding that additional information, calling it a tank top, t-shirt, sweatshirt, just helps us classify that item a little bit better. So similarly, having different definitions, different words for a polynomial, a quadratic, and power function, even though there's some overlapping concepts there, helps us just talk more specifically about the type of function we're dealing with. So let's work on identifying first a power function. Keep in mind what we're looking for is a polynomial with a single term. That means f of x is out. This can't be a power function, it has too many terms. N of x might not look incredibly obvious right from the start, but knowing that we can use properties of exponents to multiply those powers together, this is the same thing as x to the 24th power. Meaning what we have is a single term, a single x variable raised to a power. So n of x is a power function. Q of x has too many terms, so we'll throw that out. B of x, again, has too many terms, so we'll throw that out. And d of x can look suspiciously like a power function, but we want to be careful here because in this case what we have is a number raised to a variable, which is not the same thing as a variable raised to a number. N of x equals x to the 24th power is a variable raised to a number, but d of x equals 3 to the x power is a number raised to a variable. That type of function has a different name. We'll cover that later. For now, it's important to know that it's not a power function. In example 2, we want to identify all of the polynomial functions. F of x is a polynomial function because it has one or more terms, each with a variable, an exponent, and a coefficient, which, let me go back and clarify that that variable should be a whole number. I'm sorry, not the variable. That exponent, the power that we raise it to, needs to be a whole number. So if we have fractional powers or negative powers, that would not be a polynomial. We have to have a whole number value for each of those exponents to be a polynomial. N of x, we already found, is x to the 24th power. That's a power function, but all power functions are also polynomials, so that would count. But it would be more precise to refer to it as a power function. Q of x is the quotient of two polynomial functions. So we're taking one polynomial divided by another. That has another name that's actually referred to as a rational function. So not a polynomial. B of x doesn't initially look like our same pattern, but if we multiplied this out, we would get 5x squared plus x minus 10x minus 2, which would be the same thing as 40x squared minus 72x minus 16. And now we have all of those components. We have one or more variable terms with a whole number exponent and a coefficient. So b of x is a polynomial function, and again, 3 to the x power is not, because we need a variable raised to a number, not a number raised to a variable power.